Now we're looking at checkpoint 2.4, problem number 2. This is an enrichment problem. So note that this equation has two square roots. That means that we're going to have to do some similar strategies that we did to number 1, where we have to isolate the root and then square both sides. We're going to end up having to do that a couple of times. This is going to be a pretty long problem. And it is an enrichment problem. You won't be tested on solving equations with two square roots, but if you are serious about your math education and you plan to go on to take like higher level calculus courses, then it is in your best interest that you know how to do these things. Not because you're going to be doing this in calculus, but just because this develops your algebraic foundations for you to be able to handle anything that a future higher level math teacher might throw at you in terms of algebra. So let's go ahead and dive in. I do need to isolate one of the roots. I either need to get this one by itself or I need to get this one by itself. It doesn't matter which one. It looks like it's going to be pretty easy for me to add this one, the second one, over to the right side. So that's what I'm going to do, is I'm going to add that over to the right side. We're going to get square root of 2x plus 7 all by its lonesome over on the left side of the equation. What an ugly looking plus sign, good grief. Is equal to, I was going to write -1 plus the root. I think I'd rather just write down the root first, the square root of x plus 7, and then minus 1. I like the way that that looks. Now I do need to square both sides because the 2x plus 7 is trapped inside of a root, and I would like to cancel that root to free the 2x plus 7 from the inside of it. So on the left side, we're just going to get 2x plus 7. On the right side, this is going to be messy, unfortunately, but there's not really a better way to go about it. We just kind of have to grind through it. So just like in problem number 1, I'm going to be writing down these parentheses twice, square root of x plus 7 minus 1, and then another square root of x plus 7 minus 1, because it's being squared. And I'm going to have to FOIL this out. I'm going to have to go uh, root x plus 7 times root x plus 7, and then outside, inside, last, and just go through that whole FOIL distributing process. The left side is 2x plus 7. On the right side, let's do some color coding. Hopefully this doesn't look super messy by the end of it. Root x plus 7 times root x plus 7 is just x plus 7. Whenever you take a square root and you multiply it by an exact copy of itself, then it just leaves you what's on the inside. Now I'm going to do root x plus 7 times -1, which is just going to be negative root x plus 7. I'm going to do the next one in the same color because they're actually going to end up being like terms. So -1 times root x plus 7 is negative root x plus 7. I'll be combining those two like terms. And then we'll do a different color for the last one. Let's go orange. Why not? Is that orange or is that yellow? I don't know. -1 times -1 is +1. +1. All right, so that's what's going on the right side. Now on the right side, I'm going to combine like terms. Left side is just 2x plus 7. Right side, this x can't be combined with anything, so I'm just going to write down the x. The 7 can be combined with the +1. Those are like terms. So 7 plus 1 makes 8. So I'll go x plus 8. And then we have a root x plus 7 and a root x plus 7. They have a coefficient of -1. So -1 combined with -1 makes -2. This would be very similar to, say, like negative b minus b. If you have negative b minus b, that's -2b. I mean, that's what we're doing. Instead of just a single letter, it's an entire root, but it is a matching root. So we can combine those and make it -2 root x plus 7. Okay, so I'm going to take a moment to look at where I've been and where I'm at now. So at the very beginning of the problem, we had two square roots. Now I've only got one square root. So I've made progress, but I am going to have to kind of redo what I've done. I need to isolate this root and then square both sides. So I'm going to move this x over to the left side. I'll move this 8 over to the left side. I'll show my work in red here. I'm going to subtract x. I'm going to subtract x. I'm going to subtract 8. I'm going to subtract 8. Trying to get the root by itself. Let me scooch down and make some more room. This is a long problem, and that's okay. X minus 1 is equal to negative 2 root x plus 7. I don't really like that there's a negative here. I don't really like that there's a 2 here. Sometimes you have a GCF across the entire equation, like everything could be divided by 2. You could do that if you wanted to. In this case, you would end up with fractions on the left side, and I don't want to create fractions. So even though I don't like that my root has a coefficient, it's okay. I can deal with it. I'm going to square the left side, and I'm going to square the right side. The reason is because I want to cancel out the square root. So it's going to cancel. On the left side, I'll have to double those parentheses, right? X minus 1 times x minus 1, getting ready for that distributing FOIL process. On the right side, we have a coefficient this time. I do need to be careful about that. We've got negative 2 squared. Negative 2 squared is 4. And then we have x plus 7 inside of a root being squared, which means that that root is just going to cancel out. Be very careful here because you could easily make a mistake. Currently, what I have written down is wrong. That x plus 7, that's a binomial being multiplied by something. I need to make sure I continue to represent that binomial as being multiplied by the coefficient in front. If I didn't put the parentheses, it looks like the 4 is only being multiplied by x. That's not true. The 4 is being multiplied by the entire binomial. That's why I have to put it in parentheses. So it's an easy thing to make a mistake on. Moving forward, we're going to do some distributing. The left side will go through the FOIL process. I am going to skip a step and just go ahead and combine my like terms. So we'll have x squared minus 2x plus 1 equals, on the right side, I'll distribute my 4, and we get 4x plus 28. Now I finally have a quadratic. So no more square roots for me to deal with. I do need to move everything over to the left side. So we're going to get x squared minus 6x minus 27 equals 0. Oh, I didn't show my work on that. I could have done that in red. I could have done minus 4x, minus 4x, minus 28, minus 28, even though I didn't do it. If you would like to, go ahead and do that. Make your work make sense to you. Um, Now I need to see if I can factor this. I need factors of negative 27 that add up to negative 6. I think 9 and 3 should do it. I'll be careful about my negatives. So we're going to go x here. We're going to go x here. We're going to go 9 and 3. The middle term is negative, so my bigger one needs to be negative. And then this negative 27 has got to multiply to a negative, so I've got to have a positive here. And I can double check. Negative 9 times 3 is negative 27. If you FOIL and combine your middle terms, you'll get negative 6x. So equals 0. And then I'll set each of these binomials equal to 0 on their own. X minus 9 equals 0. X plus 3 equals 0. And so then we get x equals 9 and x equals negative 3. Be careful about circling those as your final answer because it is very likely that we have extraneous solutions. Goodness, is that the beginning of the problem? That's the previous problem. Yeah, wow, that's a big problem. We got through it. That's okay. So I'm going to take this 9, plug it in, see if it balances. I'll take this negative 3, plug it in, see if it balances. I'll do it in purple. Purple's a good color. So we've got square root 2 times, I'll plug in my 9, plus 7 minus a square root. Remember, we're still plugging in 9, plus 7 equals negative 1. 2 times 9 is 18. 18 plus 7 is 25. Root 25 is 5. 9 plus 7 is 16. Root 16 is 4. So we get 5 minus 4 is negative 1. Nope. That's not true. So x minus x equals 9 is an extraneous solution. I'm just going to cross that out. Let's check to see if plugging in -3 works. It is possible that neither of these will work. That doesn't usually happen, but mathematically is possible. If I find that neither of them work, that would make me feel pretty skeptical and make me feel like I did something wrong. So I would probably graph this equation and just look at a picture of what's going on and see if that can help me make sense of it. But let's see if this works. 2 times -3 is -6. -6 plus 7 is 1. Root 1 is 1. -3 plus 7 is 4. Root 4 is 2. 1 minus 2 is -1. Hey, that works. Yeah, for sure. So that means that x equals -3 is the only solution to this equation.